Dankjewel, Ron. Nee, dat, ja, mag mij introduceren hoor, daar niet van. Nederlands of Engels? What's het makkelijkste? English, is that okay? Yeah. Is that okay for everyone? Cool. First of all, thank you, Ron, for having us here again. You know, one of those situations where whenever I call Ron and I say, you know, I'd love to do a meetup, he says, of course you can. And that's very much appreciated. We like it a lot, and you're great hosts and a great venue, and thank you again. So yeah, we wanted to get it one more time before summer because there's so many things to talk about, but also just to get to keep the community going. I want to kind of start by saying that you know, after summer we're really looking for agenda items and things for people to talk about, and things that always work is, you know, customer experiences or user experiences. So if you feel like you have an interesting story to talk about with regards to graph databases, not you, Ruben, because you've been here too many times, but you can always reach out to me or Kees or Ron, and we will absolutely make the time and the effort to promote it and to make sure that we have a nice story. It's usually also the meetups where most people come when we have nice stories, right? So, but before summertime, we felt like we had a lot of things to say, because there's a lot of new stuff coming out of, you know, in the graph database market in general, I would say, but also at Neo4j. A lot of stuff has happened in the past 6 months, and we're going to do tonight's meetup basically around 2 topics. And the first one is around Neo4j 3.4, which is the current shipping release, or the currently available release of Neo4j, which is still, I think, one of the leading graph databases out there. And then we'll talk a little bit about a topic that we've actually touched upon a couple of times already in this meetup, which is visualization and discovery. We've had a couple of people speak about it here as well. I remember when Tom Zeppeveld, who's not here tonight, but he presented their Interactor product here some while ago, which obviously is a great product. But we're going to talk a little bit about a tool set that's coming out from Neo4j, which is called Bloom. That's going to be Kees. Kees is going to talk about that after I race for the airport. So I have to leave during the break, unfortunately. But I'm happy to have a chat about 3.4, unless there's other things that you guys want to talk about. I mean, we're a small group, so we can always, you know, steer it whatever way we want. Don't have that many slides either, so we can tweak it. Why don't I get started with the 3.4 topic? Is that okay? So Neo4j, right? So 3.4. I mean, I think it's fair to say that we've come a long way. When I started working for Neo4j 6 years ago, we were at 1.7, and that product is so far away from the current product. It's almost difficult to believe it. It's you know, that was the time when Cypher had just been released. It didn't exist before then, but it was not for writing yet. You couldn't write to the database with Cypher. You could only read from the database. That's only 6 years ago, right? It's come a very long way. And you know, I guess the market has come a long way as well, right? I mean, there's Neo4j is still a very, very popular open source project, but it's also a very popular piece of enterprise software these days, with lots of big organizations using it in lots of different use cases. So let me give you a little bit of an update on what's in the 3.4 release. It's quite a big release, if I'm honest. There's a lot of new stuff in there. And some of the things that we've done in the 3.4 release are super hardcore and very, very technical. And so I won't understand half of it, but it's very, very deep in the database. And it just kind of testifies to the fact that, there's a lot of complex hardcore software engineering needed to build a great database. And obviously, it's harder, better, faster, stronger than every previous release, right? So, it is a very, very, very good release. But it's also a release which we think is very important because, what we're trying to do is build lots of things around it, right? If you look at Neo4j's strategy, at least, it's very much around, building things around the graph database that make it easier, make it more valuable, make it more accessible for people to use graphs in their daily operations and build business applications on top of it. Right, so there's a lot of tools around that core database that are either releasing very, very soon or releasing later this year that are going to reside on top of this 3.4 release. So guess what? It's an important release for us. We're going to be stuck with this for a while. I mean, what we see as the graph platform, it's things like data integration. We talked about this a little bit earlier. We're investing a lot of time and effort in making it easier for people to load data into Neo4j and to read data, bulk data out of Neo4j, both with traditional data systems like relational systems, but also big data systems, Hadoop, Spark. We were even going as far as making it possible for people to really have a very tight integration between big data platforms like Apache Spark by running Cypher queries on top of Spark. That's the analytical tooling that you see on the right-hand side here. We're going to release, or it's actually already on GitHub. You can look at it right now. You can run Cypher queries on top of Spark these days, which is great for these analytical workloads where you want to harness the power of very big numbers of systems, right? Distribute the workload across lots of different systems and get those analytical results back more quickly, right? I was talking about the data integration piece. I think it's also useful to mention that originally we actually had a third topic for tonight, right? But we couldn't make it happen. We've hired a bunch of people that have a lot of experience with ETL tooling. I'm not sure if you're familiar with the Kettle project, the Pentaho Kettle project, PDI. It's a very popular open source data integration project. And actually the founder of that project is now at Neo4j. And a bunch of people around him as well, and you will see a lot more noise and hopefully also tools and products around data integration from Neo4j, because it's just a critical piece for us to get graphs out there more quickly. We need to be able to integrate with lots of different stuff. And then we talked a little bit about the drivers already, maybe making it easier for people to develop applications on top of graphs. And Case is going to talk a lot about discovery and visualization, which is exposing the power of graph databases to business audiences, non-technical audiences. Right? So we'll talk about that a little bit later. So bigger, faster, better, harder, whatever, more beautiful. Neo4j 3.4. I guess this kind of summarizes the end result is, a huge gap in performances. And I'm sure this is not in every workload, right? You will probably find that for your workload, it's not as much or a little bit less or maybe a little bit more. It will be, this is an average. This is what we see in our lab when we compare different versions of Neo4j, right? Look at 2.2 over here, and this is 3.4. We've made a huge improvement again, and I'll try to explain why that is. Well, the first reason is this thing here. It's native string indexes. I don't know if you're familiar with this, but Neo4j has always used a third-party system for indexing, right? When you used to back in the day in the Java API, you know, when you were creating indexes on top of the graph to get access to the graph, you would use Lucene, right? The Apache Lucene project, which is the foundation that not only that we use, but also things like Elasticsearch use Lucene under the hood as well, right? It's a powerful full-text search indexing system, right? Which we've used for years and years and years to give us access to the graph, right? That entry point into your graph query. Now, Lucene is good at many different things, but very small atomary, you know, string lookups probably isn't its forte, right? And what we saw when we knew, we've known this for quite some time, when we look at write performance, specifically write performance of Neo4j, 80% of the time is lost in Lucene. And so it's a huge piece of overhead. I mean, there's a lot of benefits to it, and I don't want to diss Lucene, right? That's absolutely not, but it's just, it was a great tool for us to get indexing started in the graph, but it's kind of lived its purpose. And we found that over the past couple of releases, ever since, you know, 3.2 over here, you know, we've actually done a lot of work to replace Lucene with a native indexing system, right? It's actually not replace, it's actually fusing it together. You know, we still want to use Lucene for what it's really good at, which is indexing documents, right? But we want to use different technologies for example, string indexes or for numeric indexes. We want to use a different strategy there. And we've been implementing that since 3.3 and now 3.4. And string indexes is a big part of what we're seeing in the write performance jump in 3.4. It's a big, big difference. The other biggest improvement that you'll see is, I guess, this thing, the slotted runtime. I'm hoping that most of you know what Cypher is, right? The declarative language to interact with the graph, right? It's a declarative language, which is already a big jump from an imperative language that we used to have. But it's declarative, so that means that we have to understand what you're asking for, what you declare, right? And we have to try and figure out what is the optimal way of getting you a response, right? And that's a big job. You know, you have to understand what's being declared, and then you have to formulate a strategy to get to that result, and then that strategy needs to be executed, compiled and executed. You know, there's a lot of steps in between there. And we've been optimizing the Cypher query planner for a long time. We went from a rule-based planner, which is it's basically a tree, right? You say, okay, this is what I'm being asked, so that's when I do this, and then I do that, and then I do that, right? It's like a tree structure that has rule-based, right? And that worked pretty well for longest time, but it didn't take into account the structure of your data, right? It was rule-based. It was like formally described beforehand, independent of the structure of your data set. It would follow a set of rules and get to the result, right? This is how relational databases started as well, right? The relational query planners were rule-based, you know, throughout the 80s and 90s. Early 2000s, Oracle got a cost-based planner. Early 2000s, right? This is pretty recent. We've implemented a cost-based planner for graph queries. I think it was 3.2 or 3.1. 2.4. It was 2 dot something? Okay, okay. Yeah, before 3. Okay, cost-based planner, right? So just to illustrate that we did a lot of work on this before, and then we've been optimizing this planner, and now we've come to a place where we've actually done another big optimization step, which is this slotted runtime. And slotted runtime basically means that in this declarative in this process of the declarative query language, where we go from a declaration, an interpretation, plan, a compilation, and execution, right? In that whole process, we use different data structures. Internally within Neo4j, within the Cypher runtime, we used to use a lot of maps, and now we've actually transformed that into arrays. It uses a very different data structure, and apparently that's a big win. And maybe, do you want to add something to that, or
no,
that's probably it, right?
Basically, in all the intermediate steps for the query engine, so if you do a with or whatever, there's records coming in, and then to the next one. It was always for every record a complete map. So with the keys and the values. And now they changed that by one row with a header, and then the rest is all data records. So it reduces the memory footprint by 25%, something like that. Yeah. So makes it faster and also better for the runtime itself.
So summary, there's a lot of improvements on you know, how you interact with the database. The biggest jumps are related to the indexing system and to this new runtime for Cypher. The runtime, you know, you probably don't see that when you run a Cypher query, right? But if you profile a query, it will tell you which runtime is being used. And you can also force it to use a particular runtime. Right? You can say, you know, I want to use this one. Because for some queries, that actually is a better way of doing things. So that's one important thing. Yep.
Okay,
yep.
What's also important that the transaction memory, so if you are creating structures and you want to commit it, is in this version is off heap. So you don't have to find a garbage collector. This is one step, and it will be new in following versions. I don't know exactly. Is that also a big transaction can also be
spooled.
It can be placed on disk, and not that you not pushing away all other processes on machines.
One of the biggest problems with Neo4j right now, I find at least, is that it degrades like a motherfucker. It's not very handsome in degrading. When it runs out of memory, it goes boom, right? And it doesn't warn you. And part of that is because of the fact that the memory management is actually not in our control. It's done by the Java virtual machine. And we've been moving lots of stuff off heap so that we can get more control over that memory management. And the transaction management is actually, so I think it's probably the last one that we haven't done off heap. Like the page cache is already off heap, right? Okay. So performance improvements, test it out, I would say. Check it out, see what happens, and give us feedback, hopefully. But it should be a lot better. I mean, when we release a piece of software, when we test Neo4j, last time I checked, they had about 78,000 test runs for every release, so a big number of tests that they do. And you know, you cannot test everything, but you know, we're seeing a good improvement. Right. Next one, a big set of features. When we used to have a clustering system in Neo4j based on master-slave. I'm hoping you still remember that, the high availability system, which was based on the Paxos protocol, right? Which you know, you would have one master, it would usually get all your writes, and it would replicate the data into the slaves, and they would eventually get the same data set, and you could query both. That served us well. The only thing where it kind of sucked was when the master became unavailable, right? Because then you would need to do a re-election of the new master. If the new master came online, but the old master was still taking requests, you would get a split brain, right? You would get two parts of the data, and they would be inconsistent. You would have all the data, right? You wouldn't lose any data, but you would need to figure out, you know, how do I put it back together? And that was a shitty thing to do. Am I not doing this the right way? Okay. Should I just stand still and, you know, pray? You know I'm bad at that, so. So that was the HA system. We implemented a different clustering and consensus topology in 3.1 originally, I think. And that was based on a different protocol called RAFT, right? The RAFT protocol, which is what we also sometimes refer to it as causal clustering, because it's basically a masterless setup, right? Or there's always, you know, we don't call them masters anymore. There's core servers and there's edge servers. There's always more than one core, right? And they have to agree whether or not to allow a transaction so that you cannot get that split brain anymore, right? So all of this is on a path, right? We're implementing these things step by step because we want to get to a very different type of system. We want to get to a highly distributed type of graph database that is still ACID compliant, that is still, you know, providing high performance querying and all of that stuff. So the next step after RAFT is this thing. It's what we call multi-clustering. For lack of a better word, I think you could also refer to it as multi-tenancy in a way. It's the possibility to have one system host more than one graph database, right? And for those, for that one system to act and be managed like one, you know, multi-geography, multi-data center, multi-graph type of system, so that you could, for example, say, you know, there's one graph system, but part of it is serving Europe or Norway, part of it is serving Sweden, part of it is serving the Netherlands, you know, and they would belong to the same cluster setup, but serve completely different types of requests. And the entire system, but back into the client APIs, the client drivers would be aware of the topology. Right? So you could know where your requests would need to be directed. Right? So it has a discovery service, it has namespaces. We also refer to it as shared nothing sharding, right? So we split the graph into multiple shards, but they don't share anything, and you actually can't go from one part of the graph to the next part of the graph, right? Guess what? The next iteration of this is going to be all about shared something sharding, right? Where we do want to be able to have traversals that go from one part of the graph to the next part of the graph, right? And query across those, which would, of course, be super useful for large data volumes and large and complex problems. So that's kind of the big enterprise type of feature in the 3.4 release, multiple graph clusters. We talked about this one actually already, the slotted runtime, right? But also very important in the new release and the new Cypher language support is that we've added some long and heavily requested data types to Cypher. One for dates and the other one for geospatial information. I'll actually show you that in a little bit. I'd like to give you a quick demo of what that looks like. Date time support means that you can actually have a property on a node that represents date time information, and you can index that and you can query that very efficiently without having to, you know, go back and forth from some kind of epoch number into long integers into whatever, or it's just a natively supported format. And geolocation is where we're actually trying to integrate some of the lessons learned from the geospatial plugins that have existed for a long time for Neo4j, and bring that into the native graph so that you can ask distance questions, different radial distance, 3D, even different dimensions. You can ask those types of things without having to jump through hoops, right? So those are big Cypher updates that we have right now. Some operational stuff that's changed in 3.4. A big one is rolling upgrades. I have to admit that I don't know exactly how that works, but within the same point release of Neo4j, you can just upgrade the cluster without any downtime, right? Which used to be necessary. There were lots of workarounds in the past, but now we have a systematic way of doing that. We also have a very simple but very powerful reheating strategy for the cache of a particular Neo4j instance. As you probably can imagine, for any database, caching is important, right? If you can fit stuff into memory, you want it to fit into memory. And you also want it to be able to do that, to load those caches quickly. If you have to do a reboot or anything, that the cache state of the system would automatically be repopulated, so that you don't have to wait for it to populate itself before the application gets the performance that it needs. Faster backups. There's been some operational improvements in the way that we do backups on the Neo4j cluster, so that works a lot faster. It can also recover a lot faster if it fails. And then a big one that our enterprise clients have liked for a long time. We've done a lot of work on securing Neo4j a lot better by doing things like, is that me or is that I don't know what the noise is coming from. I don't know. It's not me. Yeah, I don't know what I'm doing. Don't know. Is it this thing? No. Hello? No. We'll have to work with it. We've done a lot of work on security by integrating it with things like Active Directory or OpenLDAP, by providing things like Kerberos authentication on the database, by providing things like subgraph security, right, where you can only access a part of the graph. Now we've extended that to a level that should be used with absolute care, which is property level security. That's not me, right? That can't be me. This is going to be so funny on YouTube. It's when you Oké. Dan gaan we dat proberen, hè? Ja. Ik heb hem op mute gezet nu. Property level security, which is, it does what it says, right? It allows you to not just take a look at a part of the graph and say, okay, you can only access that and you can only access that part of the graph, but really say on the node level, you know, there's certain properties that are accessible, yes or no, right? Which is something you should use with care, right? If that level of fine-grained security does not come free, right? It means that the database needs to do a lot more work before it can actually return any queries. So you should take good care when you implement that. I'm guessing everyone knows that Neo4j has different editions, right? There's the free open source community edition, and then there's the enterprise edition. There's a bunch of features that go into the community edition that are available to everyone for free, but obviously there's a number of other features that are not available to the community edition, or that would require a lot more work on the community edition. And this is a little bit of an overview of that, right? The community edition has the data types, has the string in the indexing, has the new runtime, or actually it has a specific version of the runtime. It has the bulk importer, but the enterprise edition has a lot more, right? So the multi-clustering, cache warming, rolling upgrades, you can read this, right? There's the, you know, I think we pride ourselves in making sure that Neo4j will be around in 10 years from now. And that means that we need a revenue model, and that means that we need a enterprise version that people want to pay for, right? But, you know, I think the community edition still is an extremely solid product for lots of different reasons. And by the way, the enterprise edition is free for development use. You can just download the enterprise edition as part of Neo4j desktop and go wild with it. Right. So maybe I should give a quick little demo of these new Cypher features. This is when the headset would really help. Case is going to be my headset. That's great. I'm going to be with my back towards the camera all the time. That's not good. Let me show you a couple of things. Right, so if you're not familiar with this yet, this is the Neo4j desktop, right? Neo4j desktop is what you can download for free today. It's like a management system around your graph database where you can have different projects, different Neo4j servers, but also manage, you know, like the log files. You can interact with it with the terminal. You can easily manage the settings, install plugins, upgrade it. You know, there's a lot of really, really good functionality in the desktop. Actually, if you have other projects and other applications and you have licenses for those, then you can actually launch these from here, right? So you can just add more applications to it or add more plugins to it really easily. So I've got a little instance running here. And actually what I wanted to show you is you can actually play with this yourself by going to the sandbox environment. I don't know if people are familiar with this, but if you don't want to install or you can't install Neo4j desktop, then you can actually just fire up a Neo4j instance on the sandbox environment. And it has like a bunch of different, you know, play data sets preloaded. Some really fun ones like the Twitter trolls or the, you know, the Paradise Papers or, you know, the Legis graphs. You know, there's some really cool data sets in there already. And one of them has a specific data set to have fun with the 3.4 version. I've got it running here as well. But I also have it as part of my desktop here. And it will start what we call a guide. And a guide is, it's like a learning environment. You have it with, you can start another guide here about graph fundamentals, or you can jump into code and write some movie graph or whatever. But there's a guide for, explaining some of the 3.4 features as well. Right? So if you do play and then this URL, right, then it launches this little pane here that allows you to just run through it. It will try to explain the temporal and the spatial data types for you. Very simple, by creating a little graph, right? I run that. It actually was already there, so I don't need to worry about that. And then it gives you some examples of how you can, for example, calculate the difference in age here. Right? So what I've got here is a very small graph, right? I've got a couple of people. Just let me show you. I've got a couple of people here, and I've got a movie, and the people have properties that relate to their birth dates, right, and their place of birth, right? And that's what I'm going to be playing around with, right? So if I want to calculate the age difference between, let's see here, Keanu Reeves and Carrie-Anne Moss, then I can write a very simple cipher statement that grabs those two nodes, right? Match Keanu, match Carrie-Anne Moss, right? And then it's going to calculate the between duration between Keanu.born and Carrie.born, 2 dates, right? And it's going to return that as a age difference, and it's going to pass on the Carrie node and the Keanu node. And then the result of the query is going to be the birth date of Keanu, the birth date of Carrie, and then the age difference in years, months, and days format. Right? Because it already knows that this thing is a date. Right? It knows that this particular property of this particular node is of that particular type, so it knows how to interact with that and how to calculate that. So it's got the birth date of Keanu, the birth date of Carrie. It's got 2 years difference, right? 76. So this is September 64 and August 67. So that's 2 years and 11 months or something like that, right? 11 months difference and 19 days. Right? So I don't need to do anything special for that. I can just use the temporal data types here. Part 2, yeah, you can do this in a different way as well. You match for the two. Excuse me? Why is there a return? Oh, Jesus. Why is that? Because I don't know.
I think he doesn't know age difference dot days.
Yeah, days.
He tried to resolve it as a label or a relationship.
Yeah. I don't know why that is. The query works fine.
Yeah.
I think.
There's no property called days.
Yeah.
The syntax checker is sometimes overactive.
Yeah. So it works fine. I think there might be a little bit of a glitch there, but
false positive.
yeah. Where was I? Let me go back to the guide here, because Ron, you were telling me that you couldn't compare dates. I think you can, or at least it's an example that they illustrate here.
You cannot compare durations.
You have to use special function.
Okay. All right. So what you do here is grab the 2 people, and then you. This is actually a function that verifies whether or not Keanu is born before Lawrence, and it will give you a false or a true in return. Right. So this is false. So this Keanu is born in 64, Lawrence is born in 61, so therefore it's false, right? Because it knows about the types and it knows how to evaluate that, right? Comparing dates, there's another one here. You can, so there is a duration function here. So I don't know if this answers your question, guys.
So you just create here a duration object with 2 years in it.
Yeah. I know, okay, yeah.
So you add two years to the date
Right.
object of this.
So what you're looking for here is you're looking for a person P, right, who is born within 2 years of Hugo, right? And the way you do that is you look up Hugo, you look up any person, and P dot born should be larger than Hugo dot born plus 2 years.
After 2
What
years.
I'd like to do is get the duration between P born and Hugo born, and that needs to be smaller than duration 2 years. That would be
Which is
It's possible,
durations.
maybe we can play with it later.
also, maybe I should have illustrated that before, but if you profile these queries, right, then actually not this one.
Cartesian product is always good to show.
Yeah. So if you do this one, right? No. Which one was it? Oh no, I'm in the wrong part. Yeah, I'm in the wrong part. You can show that with the next part, which is the geospatial piece, right? The other data type, where here all I'm doing is adding geospatial characteristics to the different nodes that I have in here. Then you can, similar to what you had in the time data type, you can actually, it knows about location, right? It knows about this new data type, so therefore you can perform different specific functions on it, like for example the distance function, right? So Keanu and Gary both have these spatial coordinates now. And with the return distance function, it will give me this is in meters, I believe, the distance between what Keanu does, right? So if I do this, star, it gives me Keanu, right? So it has 2 points. This one has a point, this one has a point, right? And that previous query calculates the distance between those 2 points.
If you have points based like this, then it always return meters. But you can also have another. It can be 3-dimensional, also this one. But you can also have other point definition, which is more vector based. And you get just a number like that.
Yeah.
This is the mostly used latitude, longitude, that kind of stuff.
So if you, for example, you want to use that for looking at people that are close to a particular location, like for example, Seattle, right? Seattle has this particular location, right? I want to figure out what the distance is between a person and Seattle, right? And it needs to be within 200 kilometers, right? Then it will do that filtering for me, right? And it gives me one person back. And I think if I profile this one, then it will actually show me that it uses a specific index for this, which is the spatial index that we put on this particular spatial property.
Is that a native index or?
Native.
Yeah, it's a native index.
Datetime and spatial on native.
Right. Other example here is people away, well, that's the same thing, away from Seattle. So that's That's basically it. Cool. That was kind of what I wanted to show. There's a little summary here, right? We talked a lot about scalability and performance. We talked about security capabilities, location-based and date-time type-based search, and then a couple of these operational advantages that you see in 3.4. And you should take it for a spin. Yeah. Any comments or questions? Yeah. I don't know that. Do you know that case? If the backup is. I think. Yeah, I don't know. We can check. We can find out. Anyone else have a comment?
Yeah. I'm very excited about the date-time data type. It's excellent. Especially I'm doing a lot of work with fraud detection, and that will be very useful. So as I understand it, you'll be able to query, for instance, a date range and extract out a subgraph from a date range.
Yeah.
That's very exciting.
Yes. Anything else? I hope it was useful. Take it for a spin. So we're going to change laptops. I'm going to race to the airport, and Casey is going to show you the second part of tonight's presentation setup, which is all about this visualization and discovery toolset called Neo4j Bloom. But thanks again for coming, and hope it was useful.